So let's go to our first example. I'm going to go to a proportion example. Go to slide 38. How large of a sample would be necessary to estimate the true proportion of defective parts or defects in a large population with plus or minus 3%, and you want 95% confidence? Assume that the sample proportion yields 12%, 0.12. You have all the numbers necessary now. Here's the setup. Here's where all the points are, the setup, and then you got to show me some math. First of all, am I using the top equation, sample size for a mean, or the bottom equation, sample size for a proportion? Bottom, exactly. So, how are we going to find Z? You're going to be, if this is a quiz question, and it will be, you're asked to give me the Excel equation to find either Z or T. But there is no T to find. It will probably just say, give me the Excel equation to find Z. So lately we've been using, here they are, NORM.INV and NORM.S.INV. Let me go back to NORM.S, because this is the one that seemed like everybody liked on the homework. And that's where you only have to put in then the confidence plus half the significance. Where over here, if you use NORM.INV, you gotta use the first number is the confidence plus half the significance, but the second number is 0, the third number is a 1, always. So you just save a little work if you want to use the NORM.S, and you just put in the confidence plus half the significance is your first number to find Z. So help me write this one. You said we're using this bottom equation. The first part of this was the homework question or a quiz question is I got to give the equal sign for the Excel equation. I'm using the NORM.S.INV. Help me out. This problem, I already forgot, so don't tell me. Hang on, I gotta remember. I gotta look. Okay, this problem, I see now how much confidence this problem's asking for. So the number inside the parentheses has to be 0.1. Not all at once. We are recording.
975.
Oh, there we go. Wow. Exactly. 975 parentheses. Because it said 95% confidence, the significance is the opposite 5%. We divide the 5% in half, which is 2.5%, add it to the 95. 97.5%, 0.975. We put that in Excel, which I was not prepared. Hang on, let me open up. Let's do it right on here. You know what, is there one on here already for 90s? What is it, 97.5, there it is right there. Equals NORM.S.INV 0.975, and I see that it ends up being 0.9599. So we can't go 3 digits because we got all those 9s there. So I'm gonna go ahead, what is it, 1.9555? 959, 960, going like that. 1.960, there's our Z. I'll put right here, Z equals 1.960. So now I can set this up. Let's go back to the problem. That's all I had to do. Is that me? All right, help me set it up. Starting here, Z squared 1.96 squared times, what proportion am I putting here?
0.12.
There you go, 0.12, 12%, 0.12 times, parentheses, 1 minus 0.12, parentheses, over, hang on, this is not writing very well, come on, over, what's on the bottom?
0.03.
I heard you say it.
0.03.
0.03, 0.03 squared. Z is being squared, that error is being squared, and then your proportion. There's the setup. There's where most of the points are, right there. Showing me this Excel equation to get your Z, setting up this equation to get the sample size number, then you do the math. You're gonna show me at least 2. You could show me Z squared, you can show me E squared, or you can show me 12% times 1 minus 12%. I need to see at least 2 details of math between the setup and the answer.
That E, it represents error, not
Error.
not E like on a calculator.
No, not E on calculator, error. I'm putting either, I should be putting error, shouldn't I? Put the word. There, error. spelling it right. R-R-O-R? Okay, error. And it'll be given to you. It will be obvious, this problematic quiz will be obvious. It will say, hey, what's the sample size you should use to have 95% confidence when you're willing to have to be within plus or minus 3%, and your sample yields a proportion of 12%. Nothing there about standard deviation. It was asking for sample size. You know it's one of these two equations. Boom, you notice this bottom one because there was no standard deviation. Now you got to start with giving me the Excel equation to get your Z, do your setup. There's a whole bunch of points. There's most of the points right there. You're now going to show me at least 2 detailed calculations and then an answer. Now, here's the bad news about the answer. You ready? You ready? Let me answer your question. Look at what we get, 450.74. That can be 450.01, and here's the weird part. You must round up. Oh my God, I gotta put that in big letters. Round up, no matter what. Let me say that again. That could be 450.1, and you gotta go to 451. You can't go down to 450. This is the least amount you can have. So you're gonna have to go to 451. That's the least amount you can have now.
Is that for both?
For both, you gotta round up. Both the equations.
So we gotta solve it further, that's what I was gonna ask.
Yeah, you gotta solve it, and then you gotta round up. But in here, you gotta show 2 calculations. Maybe that 0.03 squared, or maybe the 1.96 squared, but I need at least 2 calculation work. I need to see details, just like the homework. So someone, Jason, is it you?
So
No?
like 0, 0, 1 would still be round up, always round up, right?
Yeah, even if that were 450.0001, you've gotta round up to 451.
So if it was a flat 450 though.
Then you're fine. But the odds of that are slim.
So if there's just any decimals round up.
Any decimal, you gotta round up. That's the weird part. It's not normal. It's not normal rounding for sure.